Hello students, I am going to deliver a topic today for the article of the center of mass, and article subcategory is supposed to be the shift in the center of mass. So let me begin the article of the shift in the center of mass, if there is any. So the shift in the center of mass. Now when do we get a shift and when we don't get a shift? Check it. We have a system in which we have many particles, which is considered as a rigid body, and then we do not apply any force on it. That means the external force is supposed to be equal to 0. That's the condition. We do not apply any force on it. So if we do not apply any force on it, so what happens? The external force is equal to rate of change of linear momentum, that is a dp upon dt, and that is equal to 0 because the force is not applied. So there are two conditions in it. Since dp upon dt is equal to 0, so the force was applied if it was applied on what? Center of mass. If it is not applied, that means it is not applied on the center of mass. That means the momentum variation of the center of mass is 0. That gives us two conditions, two cases, that either the center of mass momentum is 0 definitely. So there is no variation. That means finally also it remains 0. And second, that the momentum of the center of mass was constant. So since there is no variation, so finally also it remains constant. Right? So which means that initially the center mass momentum was 0. So finally also the center mass will be equal to 0 in momentum, which means if initially COM was in state of rest, then in all future conditions, in all future condition means this remaining the prime condition. So that is supposed to be the prime condition that should remain. So in all future instance, we can say the COM will remain in state of rest. Now see, this is a theory of the center of mass, but see, we have learned it earlier that the momentum of the center of mass can be equal to the vector sum of the individual momentums. But now we are telling that this is equal to 0 at all instants because the force is not applied. But that does not mean that the independent particle do not have the momentum. So the particles of the system may or may not be in motion. It is quite possible that nothing is moving inside, but it's quite possible there is a motion inside, but the net momentum is still coming out to be 0, just like a bullet in a gun. The bullet goes forward and the recoil of the gun is backward, the net momentum stays 0. So the particles of the system may or may not be in motion. If you don't fire the bullet, then neither the bullet, neither the gun is in the motion. Correct? So we have adhered to a condition where we say that the external force is 0. So momentum change of the system will be 0. That means whatever is the initial state of the system should be the final state of the system. So if the initial state of the system is in a state of rest, so the final state should also be in a state of rest. That means at any future instant. Correct. That means the COM initially in a state of rest will finally remain in a state of rest. That means it is not able to change its position. So what is the condition from here? Therefore, the COM does not change its position. But the particles may. But the particles of the system may change their position. Just like in the case of the bulletin gun I've explained to you. Take me more example. Man jumping out of the boat when he has to reach the shore, right? So he jumps out of the boat. So what happens? He jumps forward, the boat moves backward. So if it does not require to jump, then nothing happens. So, but the particles have the freedom of movement. So the particles of the system may have a momentum, may move or shift their position. So the boat goes back and a man goes forward. So they're shifting their position because they have the momentum. That's why individual momentum. But the system momentum does not change. The system center mass does not change. may or may move or shift their position. That is a particles of the system, right? But even in short, we can say the shift in the COM, center of mass position, is zero. So can we write that delta RCM is equal to zero? Center of mass may not be at the origin; it may be at a fixed position, but in a future instant, its position is also the same. That means the shift in the center of mass is zero, while the particles, that is delta R1, may not be zero, delta R2 may not be zero. They might be changing their positions. Delta R3 may not be zero. Getting? But the shift overall should become zero. Now, how do we use it? We use it like this. Let's say we have RCM as equal to M1R1 plus M2R2 plus M3R3 and so on, divided by total mass, like this. So how do I use it? I can write this as M into RCM as equal to M1R1 and so on plus M2R2 and so on. So I can write this as M delta RCM is equal to M1 delta R1 plus M2 delta R2 and so on. But as per my concept, the delta RCM is zero. So that becomes zero as equal to M1 delta R1 plus M2 delta R2 plus M3 delta R3 and so on. So that net shift becomes zero. If I have a binary system, which system? For binary system. Binary system, we have only two particles. This means M1 delta R1 and plus M2 delta R2. That is supposed to be zero. That's for your binary system. Simple, simple. Which can also be written that M1 delta R1 is equal to minus M2 delta R2. That means one particle shifts to the left of the center of mass and one to the right, because the center of mass is not shifting. So delta R1 direction and delta R2 direction, cap means direction, are opposite. That means if this was a gun and there was a bullet inside it, this was a bullet inside it. So the bullet goes here and a gun moves here. So if the center mass was supposed to be here, so the shift of this is supposed to be positive. That is a delta R1 is positive. That shift is positive. And this is delta R2. That's a recoil of it. That shift is supposed to be what? Negative. One moves forward, one moves backward. There is a man on the edge of it, and then he jumps. He jumps. As he jumps, he reaches here. The bullet, not the bullet, the boat, it moves back. So what is happening? One of the shift is positive. The center mass of this might be lying here. So this might be the COM position for both of them. So with respect to that, what is happening? The boat center is moving back while the man is moving here. So there is the shift in the position of the man, that is delta R1, which is positive, and the shift in the position of the boat, that is delta R2, that is negative. One moves forward, one moves backward. That means this is generating a velocity here, and this is generating a velocity here. That is V1 and V2. Similarly here, that is V1 and this is V2. The conservation of momentum exists. So I said the CLM and the center of mass concepts basically go hand in hand. That's the one aspect. And what's the second aspect? The second aspect is also there. That if the center of mass is moving initially, so it will remain in the same state of movement. That means if the COM was moving with constant velocity, it still moves with that velocity, with that constant velocity. Or rather, we can also say that the COM maintains its path. So wherever it was moving, it will continue to move there. Which means, like, we talked about that if we throw an axe like this. So what happens? it follows the trajectory. So the axe position keeps on changing. It's a complicated position. The axe position. It's a complicated position. The position of the center mass of the axe, or that will be along a very complicated path. But if you check the center of it, the center of that axe, that is going to follow the same path. That is supposed to be that, just like if you were dealing with a ball. Let's say if you have a ball which is thrown. Instead of the axe, we take a ball, right? And the ball is supposed to be thrown. Now, it was following its path. Over here, some explosion took place. There was explosion here. So what happened? The particles flew away. So one particle like this, one particle like this flew away, because conserving the momentum, right? So it may fall over here. This particle may fall over here, the second particle. But the center mass still will follow the same path. There is actually nothing over there. There's actually nothing over there, but it maintains the same path. The COM maintains the same path. The reason, because there is no external force applied apart from whatever was there in beforehand. Beforehand, the condition was because of the gravity, so following that path because of the gravity, because of the explosion, nothing else happens on the system. So the system must follow the same path. So system is following the same path, while the individual particle trajectory changes. That's the trajectory of the one particle, trajectory of the second particle. And one particle lies towards the right. See this. And one particle, this is the COM. The COM follows the same path, while the particles are scattered around the center of mass. So if it is a binary particle again over here, so this is delta R1, which is positive, and this is delta R2, which is negative. So they are going to fall on both the sides of the center of mass, while the center of mass follows that path. So these are the two conditions arising from the condition that the external force is basically equal to 0. So we have many questions which are going to arise from there. So let's start practicing the questions, and the concepts come along with them. Okay, so let's do so. Now, what is happening with the first question is we have a very special problem which is coming from the ages, that is known as a man and boat, the example which is just gets above this. So what's the question? I'm going to frame, and then I'm going to explain, and then I'm going to generate the answer. So this is the boat, and this is the man. Okay, this is the man, and this is the shore of the river maybe, and this is like a kayak boat. What is a kayak boat? Which is very thin. So very thin boat. It's a long thin boat. So this length of this kayak boat is L. The mass of the man is small m, the mass of the boat is capital M, and this is the origin, let's say. Okay. Now the question is, if the man reaches the left end of the boat, find the drift of the boat. Do so. So how do I do so? So if I'm talking about that, what is happening between the man and the boat? So the man is moving here. So the friction must be acting on this, because the friction is responsible for the motion. And the boat develops a friction on this side. So we understand that why does a man move towards the left and why does a boat move towards the right? But this is our system of interest. And if it is a system of interest, so what is happening? So what is happening? The friction becomes an internal force, and therefore the external force becomes equal to 0. And so it gets into the category that the rate of the change of the momentum of the center of mass should be 0. And then it gets into the category that whether the center of mass is stationary or whether the center of mass is supposed to be in a constant motion. So we say it is stationary in this case. Reason, because individually both the particles initially were in a state of rest. Neither the man was moving initially, neither the boat was moving initially. So then they start to move. That means initially the center mass had the momentum 0. So the finally also the center mass momentum should be 0, while the individual particles may move. That is 0, but the boat may move, but the man may move, but the overall center mass must not move. Its position must not shift. The shift in the position should be equal to 0 of the center mass, while the individual particle may move, one towards the right, one towards the left. And that's on the basis of which we can solve the question in two parts, two mannerisms, two ways, two methods. The first method, the method number 1. The method 1 is in the given position, locate the COM. So locate the COM in the initial condition. So in the initial condition, I'm locating the center mass. I'm writing this as RCM in the initial condition. That is, if this is 0, 0, what are the coordinates of the man? L, 0, coordinates of the center mass of the man. And the both center is at the M1 x1 plus small m into L, M2 x2 divided by capital M plus small m. That's the initial coordinate of the center mass. Done. And now we sketch in the final condition. So we predict the final condition and relocate the COM. So let's do so. So we bring on the final condition. देखो किनारा तो कहीं नहीं जाएगा. The shore is going to be there. So what happens? The boat drifts because of this condition towards the right. So the boat reaches here and the man reaches here. The length of the boat is same, but the boat has drifted. How much? Let's say x. So the coordinate of the man becomes x, 0. And the coordinate of the center of the boat, becomes x plus L by 2, 0, where we have the mass of capital M. This is the mass small m. This is what is predicting the final condition. The boat drifts towards the right. What's the reasoning? Because there was a friction on the boat towards the right. Now in this new condition, we relocate the center mass. So relocate the center mass in this position. So M1 x1, that is small m into x, plus M2 x2, that is capital M into x plus L by 2, divided by small m plus capital M. This is the equation 1 and this is the equation 2. But our concept says the shift in the position of mass center is 0. That means the center mass initially position and the center mass, the final position, should be same because the shift is 0. It's not moving. So therefore, from 1 and 2, what we are doing? We are basically equating them. The position of center mass initially should be equal to position of the center mass finally. That's the logic. So equate it. So as we equate it, what do we get? We get initially it was capital M into L by 2 plus small m into L and divided by capital M plus small m. Right now it is small m into x plus capital M into x plus capital M into L by 2 divided by small m plus capital M. This gets cancelled out. This gets cancelled out. So it gets small m into L is equal to small m plus capital M into x, and we get the value for x. How much? That is small m into L upon small m plus capital M. That's the result. That's the result. The boat moves. This is also the distance the boat drifts with respect to the ground, with respect to ground observer. You are standing here and you observe that. You are a ground observer. So if you get a question, what is the distance traveled by man relative to the boat? So that is very simple. That is very simple. Relative to the boat means your observer is sitting here. That's the observer. And man moves where? Towards the left hand on the boat. So with respect to him, the boat is stationary with respect to this observer. Right? This is an observer, because if the question is asking relative to the boat, you bring the boat in a state of rest and then see how much the man moves. So man moves from the right hand to left hand. So what's the distance? L. So the distance traveled by the man with respect to the boat, that is equal to L. Correct? But if the question asks you that what is the distance traveled by the man with respect to ground, oh, then that is supposed to be L minus x. Because out of that L, the L actually man did not travel himself. That is only a relative idea. But actually the boat drifted this much, so the boat must drift how much? L minus x. Total distance will be hence what? L. So L minus X, that becomes L minus small m into L upon small m plus capital M, and you will get this as capital M into L upon small m plus capital M. So three different questions can be asked. There's a distance the boat drifts with respect to ground, that is X. From the ground, what did you observe? This is X. Total distance is what? L. So what is a distance drifted by the man? L minus X, simple. So relative, it is L, keeping the frame in a state of rest. You kept the frame in a state of rest, right? Correct. So the man travels relative to the boat, how much? L, out of which X is traveled by the boat. So actually the man travels how much? L minus X in opposite directions. That's it. Okay. So here comes with this knowledge, with the knowledge which I've given to you right now, there comes a method 2. And what's the method 2? Direct. What's the direct? Oh, method 2 is that a shift in the center mass is 0. Very correct. Which means M1 delta R1 and plus M2 delta R2 in vector should be 0. That means one moves towards the right, second moves towards the left. That is already depicted in the diagram. You can also write this as M1 delta R1 equal to M2 delta R2 in the magnitude. In the magnitude, they are same. So I've not written vectors now. In the vectors, it should be proper. M1 delta R1 should be minus M2 delta R2, signifying that one moves towards the right, one moves towards the left. Now simply writing scalar, then one shift towards the left, one shift towards the right. Understood है ये बात तो हम उसको लिख सकते हैं ऐसे. Now how to use this particular formula? How to use? Now how to use is M1 is supposed to be that particle. This is only applicable for the binary particle right now, 2 particle. You can also apply for 3 particle. I'm applying for the 2 particle right now. So particle whose question is asked, जिसके बारे में question पूछा गया, you consider that as M1. And then delta R1, assume its shift. That is a particle shift, जिसके बारे में question पूछा गया. So M2 is definitely the second particle. Correct. And delta R2, how you will write? Relative distance minus delta R1. Just like we did. Relative distance was how much? L. So the boat shifts how much? X. So the man should shift how much? L minus X. What is L minus X? Relative distance minus X. Relative kitna hai? L. So what is L minus X? Relative distance minus X. So that makes your life simple. If this is happening in X coordinate, you can simply write this as M into X equal to M1X equal to M2 into L minus X. That's what exactly we are doing in this question. So the question is about a boat. So the mass of the boat is capital M. Let's say it drifts how much X. The second particle is what, man? The mass is small m. And what is the distance it travels? Relative distance minus X. What's the relative distance? L. So L minus X. That's your equation. M1X1 equal to M2X. So simple. This is how we apply. The first particle, जिसके बारे में question पूछा है, X, you assume the distance which it travels equal to M2 is the mass of the second particle. In this case, that is a man. And into relative distance minus X. How do we check the relative distance? Keep the frame at rest. And see what is the displacement. So the man moved from the right hand to the left hand. So what was the relative displacement with respect to the boat? L. So how do we write X2? Relative displacement minus of X. And what is X? The absolute distance of the boat. So what is the absolute distance of the man? L minus X. Simple. That's a relative distance minus X. This solves your question. Question started here, ended here. Ended where? Just 2 steps. That is capital M into X plus small m into X is equal to small m into L. So X common, small m plus capital M is equal to small m into L. So X becomes equal to small m L upon small m plus capital M. And of course, you are getting the same answer as we developed the answer from here. So it's the same. So of course, the method 2 is simpler. It's easy and quick shot. And method 1 is a savior. It's a savior, even if the question exceeds and you sometimes don't are able to check on the relative ideas, then the question method 1 is a safe bet. And more than 2 particles, sometimes you get difficulty in writing the shift equations as pertaining to the signs, and therefore the method 1 can work for you beautifully. So I will give examples of both the methods. So let's say I have a question like this where we have 2 physics students. One is having a mass of let's say 40 kg. This is 40 kg mass, and this is 60 kg mass. And then there is supposed to be the boat, which is of 80 kg mass. This is like this. Now, this is the condition right now, and both students are physics students, the student A and the student B. Now they have to discuss a physics problem. And for discussing that, they need to meet at a center. So while they meet at a center, the boat is going to move. And how much and where does the boat move, so you need to find out. So both the physics students meet at the center. So find the drift of the boat. How much the boat drifts, you need to find out. So let's try to find this out. Okay, let's try to find this out. So how do we find it out? I am using the method number 1, in which in the current position, let's say this is 0, 0. So the length of the boat is given as 2 meter. How much? 2 meter. Right, let's say 2 meter. So the coordinate of the center of the boat is how much? 1, 0. And the coordinate of the second student becomes how much? 2, 0. So what is the position of the center mass initially? That is m1x1, so 40 into 0, plus m2x2, so 80 into 1, and plus m3x3, so 60 into 2, and divided by, that is 40 plus 80 and plus 60. Simple. 3 particles, so 3 times m1x1, m2x2, m3x3 added upon total mass. This works 80 plus 60 into 2. 60 into 2 is how much? 120. 120 plus 80 becomes how much? 200. 200 upon down, 40 plus 60, 100 plus 180. So 180. So that's 20 upon 18. So that's 10 upon 9. 10 upon 9 meters is the initial center of mass. And now finally, what do we do? So in the final condition, we don't know whether the boat is shifting towards the right or left. We assume. If we are correct, our answer will come out to be positive. Else it will come out to be negative. So then we will understand the boat drifted on the opposite side. So let's assume that the boat shifted towards the right. So this was the origin, and the boat shifted how much? X. So all the 3 are at the center. The center mass of the boat is here itself. And both of them are at the center. So the center mass has to be here itself, because everything is at the center now. Both of them meet at the center. But still, if you want to clarify, see this. XCM finally, that is equal to, what are the coordinates of this? That is x plus 1, 0. This is 1 basically. So that's x plus 1, 0. So the 40 particle is also at x plus 1. The 60 particle is also at x plus 1, and the center of the board is also at x plus 1. So divided by 40 plus 60 plus 80, that eventually comes out to be x plus 1 only. That's what I was telling. See, all of them are basically at the common point, and that's the center of mass. So someone says, is it possible that the center of mass really exists? It is existing. See there. All of the mass is there itself. But no, the board mass is not there actually. Is not there actually. Board is spread out. Okay. So that's x plus 1. Now, we have the concept external force is not 0. So the XCM initial should be equal to XCM final. And you can explain that thing, first of all. Let's see. This is a system of interest. So this is supposed to be the system of interest. And on this, the net force is 0. Right? So therefore, the shift in the position of the center of mass is 0. That's what I'm using. And if you want to further explain, so then he walks here, friction force F1. So on the board, that friction force is F1 here. And this student walks here, so that's a friction force F2. And the boat, that friction force F2 is here. And that is a system of interest on which the external force is 0. Now, the boat will drift towards the left. So drift towards the left if F1 is more than F2. And the drift is towards the right if F2 is more than F1. That's quite simple. Right? The friction coefficient may not be same. May not be same. Okay. So now from here, we quit the final position and initial position. The initial was 10 upon 9. 10 upon 9. And right now that becomes equal to how much? X plus 1. So therefore the value for the x becomes equal to 10 upon 9 minus of 1. So we get the value 1 upon 9. So that's our answer. So we are getting positive, and therefore the board is going to shift towards the right. Okay. So, and that's what's pretty much easier to understand, because this was a heavier particle. The right side was a heavier particle. So definitely F is mu into N2. So normal is heavier, so the F2 is more, and F2 is more, so the boat has to drift towards the right. And if the left side person was heavier, in that case, it will come negative. We will get an SCB problem in which the left side particle is heavier, and we will find the answer to be coming out to be negative. That means the boat is going to drift towards the left. So be careful in the questions, right? Every time it will not be there that, right, correct. And if they were supposed to be of equal masses, then nothing shifts, no? Then nothing shifts. Okay. Then the F1 and F2 will both be the same, and therefore the net friction will come out to be anyway zero on the boat, so the boat will remain stationary. So boat will not move, so center mass does not move in that case itself. So the shift in the center mass will still come out to be zero. Correct. And like the drift in the boat will also come out to be zero. So the boat will not move if both of them were of the equal mass. Right now they are not of the equal mass. Okay. So then the question is done over there. Okay. So let's move forward and look into the another question. And another question comes like we have a big hollow sphere, inside of which there is a solid sphere. There is a ball, and this is that ball. Right, this is the ball. Okay, and the radius of this one is r, and the radius of this automatically becomes how much? R by 2. The mass of this is m, and mass of this is also m, identical. So this is a thin spherical shell, and this is supposed to be the ball, and it's kept on a frictionless floor. So frictionless floor means there is no external force once again on this system of interest. So on this particular system of interest, we have external force 0. So the language frictionless floor is very important. So on the system of interest, the external force is supposed to be equal to 0, correct? So the question is, if the ball reaches lowest position if released, find the shift in the center of the shell. Correct. Now what is happening? In this position, we are deliberately kept in a state of rest. How come? We don't know. Just by some means it is kept in a state of rest. And now we release one of the particles, the second particle is forced to move. Reason, we need to keep the center mass in a state of rest. Reason, the external force is 0. So अगर मूव करेंगे तो दोनों करेंगे, नहीं तो कोई नहीं करेगा, राइट? और एक राइट को करेगा तो एक लेफ्ट को करेगा. तो ये बॉल कहाँ जाएगी? लेफ्ट को. तो स्फीयर कहाँ जाएगा? राइट को. And what will be the final diagram for that? The final diagram for this seems to be ball कहाँ जाएगी? लेफ्ट को. स्फीयर कहाँ जाएगा? राइट को. So the final diagram of this seems to be that a ball, it reaches to this position. Over here, it reaches this position. What was the initial position of it? The initial position of this was supposed to be over here. And from there, it shifts towards the left. So the center of the outer one is going towards the right. But how do we solve it? By m1 x1 equal to m2 x2, binary system. So I'm going to use m1 x1 as equal to m2 x2 and solve it. Where is the center? Where is the momentum conserved? Well, sir, you are asking about a center mass of momentum. Momentum. Where is the momentum conserved? Horizontal. Reason? Vertical में gravity लग रही है. So vertical में CLM नहीं है conserve. तो हम vertical में नहीं लगा रहे हैं, horizontal में लगा रहे हैं. तो एक condition horizontal में, इसलिए m1 x1 equal to m2 x2 लिखा है, horizontal में लिखा है, vertical में नहीं लिखा है. It's in the horizontal. Getting the point? Yes, sir. किसके बारे में क्वेश्चन पूछा हुआ है? शेल के बारे में. तो शेल का मास कितना है? स्मॉल है. उसने कितना डिस्टेंस ट्रैवल करा? x में. x लिख लेते हैं. सेकंड पार्टिकल कौन है? बॉल. तो जो बॉल है उसका मास कितना है? उसका भी m है, इनटू रिलेटिव डिस्टेंस. अब रिलेटिव डिस्टेंस सोचो. तो भाई देखो, इसका सेंटर था, दिस वाज द सेंटर ऑफ द बॉल C1, और वो जो सेंटर है, दैट सेंटर रीचेस दिस पोजीशन. The center is reaching this particular position. Okay. So as the center reaches this particular position, so what happens? There is a shift. This is a shift, but we don't check this shift because इसमें x और y दोनों mix है. हमें shift कौन सी चाहिए? X में. So what do? We connect this. We join this. So what is this distance? What is this distance? This distance, if you check, that is equal to r. This ball reaches over here, so its center reaches here, So this shift, this is x shift, and what is that equal to r? Y shift is also r. This is equal to how much? Root 2r. But we don't take that reason, because the shift which we are checking is in the x direction. Shift we are checking is in the x direction. Why so? Because external force is equal to 0 in the x direction, not in the y direction. In the y direction, the external force is not 0. Gravity is acting on it. So everything is applied in x direction only. How do we apply the conservation of linear momentum? Direction specific. So it's a direction specific idea. So m into x equal to m into, now it becomes r minus x. How much? R minus x. The shift, relative distance, how much is there? R. We assume this frame to be stationary. Just like we assume the boat to be stationary. So assume the frame to be stationary. So if we assume the frame to be stationary, what happens? You can see the shift in the center of the second particle. Like the man traveled from left hand to right hand or right hand to left hand. So what was the relative distance? L. What is the relative distance? R, in the x direction. Man was also moving in the x direction. Right, so what is x direction displacement? R. So m into r minus x. So we get 2x equal to r. So we get the value for x as equal to r by 2. Concentrate on only x, not on y. Not on x and y separately. We know in the projectile motion also, physical independence, x motion does not affect y motion does not affect x. Here the movement is along where x. The center of the shell is moving where? X only. It's not going up and down. It's moving x only. So apply the equation only along x. Be careful. That's done. There is a B part of it also. If the ball reaches left extreme, see, this arrangement will be oscillatory. The ball will reach here, then here, then the outer frame will reach here, then it will come down back, and the outer frame will come back. So the ball will be also oscillating, and that outer sphere will be also oscillating. If the ball reaches left extreme, then what happens? So the ball reaches left extreme, then find a shift in the center of the shell. Right? So let's check that. Let's check that. This is not R, this is R by 2, my friends. This is R by 2. This distance is R by 2. Just checked it wrong. That is R by 2. This is R by 2, and this will be root 2 R by 2. Sorry. So that is R by 2. This is R by 2. This is R by 2, and this is R by 4. Okay, that's my mistake. This distance is R by 2. This complete radius is supposed to be equal to R over here. So half of this is R by 2. Just a mistake in the radius. Okay. Now, if the ball reaches a left extreme, so what happens with that? So we're assuming the frame to be stationary. So the initial position of the ball was supposed to be here. And now the final position of this is where it reaches this position. So what is the shift in the center? This was C1, and it reaches here C2. And now it's easy in this case now, because you are able to see only X, so not able to see Y. But it traveled Y and came back, okay? But we are checking only the X. And what is the distance change now? Well, this time it is equal to R. Because this is R by 2 and this is R by 2. So how do we write? M1 X1, first particle, shell, distance X, second particle, ball, distance R minus X. Center to center distance, this displacement in the X, how much R? So hence we get 2x equal to R and x equal to R by 2. So that's now slightly understood. This comes here, the center shifts R by 4, and this goes here, the center further shifts R by 4. So totally becomes R by 4 plus R by 4, R by 2. Correct. Yes, next one. So the next question. The next question is in a previous problem. It goes like this. There is a shell again, like this. And there is a ball here. So this is a ball here. Like this. Right? And now this is given as a mass of 4m. And this is given as a mass of m. Correct? The radius for the bigger one is given as 5r. Let me construct the ball once again. Okay, this ball is like this. That's the mass of it, and the radius of this is r, and the radius of the bigger one is supposed to be 6 of r, like this. Okay. And the coordinates of the shell is at L, 0. The coordinate of the shell. So if the ball, this is a ball, that's a shell. If the ball reaches the left extreme, just now we did the question, find the coordinate of the center of shell, not the center of mass, the coordinate of the center of the shell. So how do we do? I've already explained to you that how to attempt the question. That is by m1x1 as equal to m2x2. And the reason for that is once again the same. If you check in the system of interest, so the net external force is 0, but where? The next external force in x is 0, not in y. In the y, there is a gravity. So how do we do it? We construct the diagram and check it. And do remember, there will be the language which will say the frictionless flow. And if it does not say, then you cannot apply this. It's a frictionless flow, correct? And what happens? This ball which was here, finally it reaches here, left extreme. So this is the center to center distance. That was C1 and this was C2. Now it's becoming simpler for you. But this complete was 6r. And this distance is how much r? So this balance distance is how much? 5r. So this is also equal to 5r. So what is the relative distance? The relative distance becomes equal to from C1 to C2. So from C1 to C2, that becomes 10 of r. Assuming this in a frame of rest. So assume the frame at rest for checking the relative idea, correct? And so what is the mass of the first particle? First particle is how much? 4m. That is for the center of the shell. So that is 4m and into x, correct? Is supposed to be equal to second particle. Second particle is a ball, the mass is m, into relative distance minus x. So relative distance is 10r and minus of x, that's it. Let m and m cancel, we get 4x equal to 10r minus x, so we get 5x equal to 10r. So we get the value for the x equal to 2r. And what is x? X is supposed to be the shift. That is the shift in the center of the shell. But my friends, the initial coordinate was how much? Initial coordinate was L, 0. So the shift, and where is the shift? Towards the right. X is coming positive towards the right because the ball shift towards the left. So the sphere, the shell shift towards the right. And hence, the final coordinates of the center of the shell should be L plus 2r, 0. Y coordinate is not changing, x coordinate. So L plus 2r, 0, right? Ball moves left, center moves towards the right of the shell. The next one. So kind of easy out questions, but very nice questions in fact, right? Now see, this is another question on the same lines. That this is an inclined plane or a wedge placed on a frictionless floor. And this angle is supposed to be theta, this height is h. And there is a block kept over here, small m, and the mass of this wedge is capital M. Find the shift in wedge, and wedge is going to shift horizontal only, okay? Wedge, the shift in the wedge, if the particle, you can see the particle that is of the mass small m, slides down through height h. Right, so that means it comes at the bottom. And what will be the shift in the wedge? See, why the shift in the wedge is just, so this is supposed to be explored. Just a second, I will just take a second. Oh, back. Oh, actually, my iPad was just getting discharged, so I had to connect it. And is It's still getting me some problem. It's not charging. Reconnect. It's not charging. Screen is also gone. So I will cut short the lecture for some time. Okay, still not charging. I don't know what's an issue, why it is not charging. It must charge. Okay, let's solve this question. Let's solve this question. Now, what happens over here? First of all, let's see that why the wedge should move. So, as it moves here, the block, there is a normal reaction here, and there is a normal reaction on the wedge. So, when you're checking the free body of the wedge, so this normal reaction has a component over here. If this angle is theta, you will find out that this angle will be theta, and therefore you will get a component n sine theta, which causes a wedge to move towards the right. And while this block is, you can see, is sliding towards the left. It has a velocity here, so it has a component here and here, which basically means it is moving down also and towards the left also. But we are interested in towards the left, because once again the external force is equal to 0 in the x direction. So we are going to use our equation m1 x1 equal to m2 x2 in the x direction, which means as this block reaches the ground level, as it reaches the ground level over here, right over here, assuming the frame in a state of rest. So assume the frame at rest. So if you're assuming this kind of frame of rest, what is happening? What is happening over here, that if it is h and this angle is supposed to be theta, if this is h and this is theta, then this distance will be how much? Can you use? Then you use tan theta is equal to h upon the distance base distance. So I'm writing this a base distance. So base becomes equal to h upon tan theta. So h upon tan theta becomes how much? H cot theta. So this distance basically becomes h cot theta. Actually, it travels this particular distance, but we are not interested in that. We're interested only in the horizontal distance with respect to the wedge. And what is that? That is h cot theta. So that is a relative distance. So the relative distance becomes how much? H cot theta. Where in x? Why we don't have to check? Because we're applying the equation in x only. So first particle is who? The wedge, capital M. What is the shift you need to check? X. Second particle is the block. What is the mass? Small m into relative distance minus x. So that is h cot theta minus x. So you have seen that all the questions are getting solved in an easier mannerism, while m1 x1 equal to m2 x. So this is all we need to apply. So we have capital M into x is equal to small m h cot theta and minus small m into x. That becomes capital M plus small m into x is equal to m h cot theta. So we are getting the value for the x as equal to mh cot theta and divided by small m plus capital M. That is supposed to be the x. Right. So let's solve another question. Another one. This is a question in which I will show you that there is a shift. There is a shift. You must be having a question where we have a shift. So the question is, a small ice block is kept in large tray, right? In a large tray. Find the shift in COM if the ice block of edge length L, assume this as a cubical ice block, completely melts. Right, so let's solve this. So now we have a large ice tray like this, and there is a ice cube over here. So just assume this as an ice cube. So assume the masses also. This is small m, this is capital M, and this is the center of the ice cube. If I consider this as an origin, So what is the height of this? That will be L by 2 because this side is L. So the coordinate of this should be x is 0. So y is L by 2. So what is the initial coordinate of the center of mass? Initial coordinate of the center of mass, that is capital M into 0. That is for the ice tray. And plus small m into L by 2 upon capital M plus small m. That's the initial. Now finally what happens? Finally, this ice cube melts. Ice tray is just like that. So ice cube melts and it forms water. It forms water. And that water height is supposed to be h. Correct? Water height is h. Now we have the h to be calculated also. That what is h? That you can calculate that m grams of ice will form m grams of water. Now m grams of ice will be the volume of the ice cube, L cube, and into density of the ice, and should be equal to the area of this base, the area of the base of the ice tray, and into h, and into density of the water. So from this you will get h as L cube into density of the ice upon area into density of the water. You can get this h, correct? Once you get that h, now where is the center of this water? That is here, where? At h by 2. So the coordinate for this will become 0 comma h by 2, and this is going to form the same m grams of water. M gram of ice will form m grams of water, but the density is different, so the volume will be different, that's it. But the mass is same, and the center of the tray is still there at 0 comma 0. So what is the new coordinate? That is a x center mass final. That is a capital M into 0 still plus small m into h by 2. Small m into h by 2 upon capital M plus small m. And now you can see there is a shift. Why there is a shift? Because the external force is not 0. Why? Because there is a melting of the ice, and the melting of the ice will be because of some amount of heat, and heat manifests itself into a kind of a force. Like we get the fuel inside of a car and manifests itself into a force, and because of which the car moves. Manifestation is a energy ka roop, right? Okay. So what is the shift equal to? The shift in the center mass will be equal to x final and minus x initial. So just subtract. That is small m into h by 2 minus small m into L by 2 and divided by capital M plus small m. So that is small m upon 2 capital M plus small m and into h minus of L. That becomes your result. And h can be calculated from there. But in this question, it is mentioned that it is a small ice block and large ice tray. Large ice tray means its area is supposed to be very large, and the small ice block means L is supposed to be small. So what is happening that L cube is small and area is large, so the H will be very, very small, and therefore H can be neglected. So if we neglect H, in that case, the shift in the center of mass will be equal to minus m into L upon 2 into capital M plus small m, and the minus sign signifies that the COM shifts down. So what I've shown you the problems in which the center mass was not shifting. I've shown you the problem in the center mass is shifting. You can have the questions like this. See, there is a man here on the platform, right? And the platform is kept on a frictionless floor. Same question. The mass of the man is small m, mass of the plank is capital M, or the platform is capital M. So what will be the equation? The equation is once again the same. That if the man reaches towards the right end, the length is L. So how much does the plank shift? So once again going to apply m1 x1 equal to m2 x2. So the plank mass is capital M. The shift will be x. The second particle is the man, and the shift will be L minus x, because relative to the plank, how much does the man moves? L. So therefore you will get capital M plus small m into x as equal to small m into L, and therefore the x will be small m into L upon small m plus capital M, once again the same. Similarly, if you get a question like this, there is this bullet inside this gun, and the length of this nozzle is supposed to be L, and then the bullet is fired. Bullet is fired. So what happens once again? How much is the recoil distance of the gun? So the mass of the bullet is small m. So किसके बारे में पूछा है? बुलेट के बारे में. तो बुलेट का मास कितना है? कैपिटल M into x is equal to small m and into L minus x, because the relative distance traveled by the bullet into the nozzle of the gun is L only. So you'll get the same answer, that is x is equal to small m into L upon small m plus capital M. Same scenarios can be fabricated into many questions, like we have this cart and there is a ring here, and this ring is having a small m mass, the cart is capital M, and this is once again the frictionless floor. And there is a rod connected to this is a rod. The rod is of length L. Rod is of length L. And then what happens? This falls. This falls. So as it falls, what is going to happen? There is the force which is going to be there, is the momentum generated, because it is going to fall. There will be the loss in the energy, and therefore it is going to make the cart move forward, because the ring will slide towards the right. No, the ring will slide towards the right. As the ring is going to slide towards the right. So what will happen? We can fabricate this into this question, that let's say this container is kept in a state of rest like this. It's fixed. And then you take this ring and take this ball like this, and this is L. And now this is released. So what will happen? What will happen that when this ball, this is a ring and this is a ball, and there is no friction here, that means the ring can easily slide on that line, on that string maybe. So as this ball comes down, so the ring is going to slide forward because the ball is moving backward. Right? So correct situation will be like this, that as this is falling, the ball is falling, so the ring is going to move here. It is going to shift from this position over here because the ball is shifting backward. So if this ball becomes completely horizontal, if the rod becomes completely horizontal, what will be the shift in the ring? So you have to consider the masses. So let's say the ring mass is supposed to be mr and mass of the ball is mb. So the question is, find the shift in the position of the ring. So we can apply m1 x1 as equal to m2 x2. Don't apply in y, because y gravity is still acting. So first ball out of which the question is asked is the ring. The distance is x. The second particle is a ball, and into L minus x once again. It can be given a d also, the length. It can be given anything, omega, anything it can be given. Any value, x, y, z, anything value. I am taking L in all the questions. So it solves with the same value, that is equal to mb into L minus mb into x. So that's mr plus mb into x as equal to mb into L. So I'm getting the same result. Correct. So that is how the questions are going to be fabricated. So all the same kind of questions, and all are based upon the same idea that the center of mass does not shift. If it shifts, then how the question is there, that also I've shown you. Of course, there will be more questions. I've given a lot of questions in the as a practice for the article, which is supposed to be the shift in the center of mass, and most questions are there in which the shift is not there. Actually, 90% questions are based upon the idea when the shift is not there, and that's pretty cool thing. See, you have the two balls here, which are moving under the effect of the mutual interactive forces. So mutual interaction is a mutual interaction. That means once again the external force is 0. And let's say m1 is more than m2, so the center of mass will be here. Now they are going to move because of the mutual attraction, because of the mutual gravitational attraction maybe. So how will they move? Let's say this is r1 and this is r2. At a future instant, this particle will come here and this particle will come here, such that the center of mass still remains here because the external force is 0, center of mass cannot shift. Now the distance will be d1 and this will be d2. And in the future instant, this will come here and this will come here. You can see the ratio of their separations is going to be the same. That is r1 dash, that is r2 dash. And then they will collide at the center of mass. And then if the collision is elastic, then they are once again going to move. They're once again going to move like this. They're once again going to move like this. They're once again going to move like this. This is because of the mutual interaction. So anytime you have m1 r1 as equal to m2 r2 here in this condition, and in the next condition you have m1 d1 as equal to m2 d2. If you divide, you'll get r1 upon d1 as equal to r2 upon d2. So you can find any missing term. The initial position is given, and then it is given that the first particle moves this much. So how much does the second particle move? So you can calculate easily from this particular equation. Right? So difference will be also the same. R1 minus D1, you can calculate over there, and R2 minus D2, that ratio will also be the same. So basically, it's a ratio which is getting same. So if the ratio of the distance is 1:2, and that will be because of the ratio of the masses. If the ratio of the masses is 2:1, the ratio of the distance will be 1:2. You're getting the point? Yes, you're getting the point. Right. So let's finish the day with this. With this particular article. Anyway, my iPad is not charging anymore, so it might just die on any moment. So I'm going to finish the lecture over here with this. Thank you very much for the lecture. Bye. Thank you.